Welcome to the 7th day of the 21-day data challenge by Lighthouse Labs. Fair warning, this video contains a solution to the challenge for today, so please attempt the problem before continuing on. Reference this video if you get stuck or want to see an alternative way to tackle the problem. I wanted to take a moment to thank everyone for leaving positive and constructive comments both in the forums and on YouTube. I appreciate them, I learned from them, and they encourage me to continue on recording. And with that said, on to the Day 7 challenge. Alright, let's go ahead and load up the Day 7 challenge. First thing we notice is that the difficulty is medium, upgrade from the easy of the previous days. Going through the challenge, it looks like we need to unpack a few boxes, but we want to help out Dot by organizing them from the lightest to the heaviest. We'll use a little bit of help today by checking out the hints. And we see that we're going to be using the bubble sort algorithm. To walk you through the example, if you take the first two digits 5 and 1, since 5 is greater than 1, we'll go ahead and swap them. And then we move on to the second pair of numbers. We're comparing 5 versus 4, and since 5 is greater than 4, we'll swap them. We continue on the path with 5 and 2, swapping them, and then finally 5 and 8. And since 5 is not greater than 8, nothing needs to be done. And this is the result of our first pass. We can see that the 4 is still misplaced here, so we do have to go through it once again. 1 and 4, no change. 4 and 2, let's flip them. 4 and 5, no change. 5 and 8, let's leave them. And then we do that over and over again until none of the numbers need to be changed. And down here we have the handy structure of this function. So let's go ahead and tackle this by pasting the example that was given to us. And to walk through this, we are using a function that we do need to eventually call. This function will take a list that we'll specify a little later, and it runs 2 for loops, and then it compares a value to the next value. So let's go ahead and break this down. Down here where it's doing the comparison, we'll go ahead and print out the values of j. If we feed this function the user boxes list that we have up here, we'll already run into a problem. I'll go ahead and run this just to show you. And the reason is because user box is not a standard list. It's a dictionary. So we want to get the length of one of the dictionary values. So I'll modify the function by specifying the dictionary pair that I want to use. So I'll use weight, and I'll update all the items to specify the weight and go ahead and run this. So we can see what's happening here. If the first value is greater than the second value, then it'll print out the index. This is still a little confusing to me, so let's go ahead and simplify this a little further. Down here, I'm just going to throw in a dummy line. Up here in the first loop, what I'm going to do is go ahead and print out I and run that. We can see that it iterates through this a total of 6 times, noting that it starts at 0 and ends at 5. And the reason being is because there are 6 elements in this list. Going down to the second loop, let's go ahead and remove this line just to reduce confusion and paste it in here, changing the variable to j. So let's see what's happening here. Go ahead and run this. So you can see it's running it 0 to 4 and then 0 to 4 again, and this is repeated a total of 6 times. So you can use the conditional statement just below as a hint. So we compare the current value to the one just after it. So let's go ahead and make this plain and simple and print that out. And so you can see that in every iteration we have the current value and then the one right after it. Now let's make this even more useful by putting in the actual weights that we're looking at. So what I'm doing is I'm printing out the value of the index we're currently evaluating, adding a colon just for visual representation. And then what I'll do is I'll throw in the current weight that we are looking at, which is the list, the dictionary value weight, and then the index that we're currently at. And then I'll do the same thing all over again, except we'll be looking at the one next to it. So j plus 1 and j plus 1. Let's go ahead and run this. So we can see in the first index we're looking at 4, in the second index we're looking at 2. So those ideally should be swapped. And then we'll go ahead, etc. so on. What we can do is we can actually just add an additional character here, and I'll use a pipe operator. Go ahead and run that, and now it's a little bit more distinct for our visual comprehension. Take a moment here to understand what's going on here and then the comparisons that we're making. Okay, so now that we have an understanding of what we're actually doing within this function, we can go ahead and make the logic changes that we need to make. So we have a conditional statement right here that compares the first index to the second index, and if it's greater, then we need to swap the 2 indexes. So what we want to do is take the first value and store it into a temporary location. Then we'll take that first value and set it equal to the second value, and then we'll take the second value and set it equal to the initial value. I'm going to remove this print statement and run this, and you can see that our list is now in order. Just to add a bit more clarity, I'm going to go ahead and print our list before run through the function and run that program again. So we can see our initial list here, which is unsorted, and our new list here that is sorted. So the bubble sort is working for us. Now the problem we have right now is that the box name hasn't been sorted either. It's still in its original additional format. So what we need to do is add the additional logic to also sort the box name at the same time. These 3 lines of code swap the weight indexes. So it's simple enough just to copy these again, paste it in here, and instead of referencing the weight, we'll reference the box name. So I'll copy and paste the box name into all these fields. We'll run the program again, and there we have it. Here's the original, and here's the updated sorted list. We need to look for an answer that contains 2, 1, 6, 5, 3, and 4. Scrolling down, go to the questions. 2, 1, 6, 5, 3, and 4. Go ahead and select that and submit the answer. And there we have it. Today's challenge was a little bit confusing. Take time to digest and understand what's happening here with the bubble sort. But as you get exposed to these sort algorithms and time goes on, you'll start to gain an understanding of what's going on. Don't worry if you had trouble with this question today. It is a more advanced concept. Continue on, continue with these challenges, and I'm sure you'll be well on your way to becoming a data scientist. I hope you got some value out of this day 7 video of the 21-day data challenge by Lighthouse Labs. I'll be back tomorrow with another video covering the day 8 challenge. See you then.